morning friends. In thermodynamics we discuss about the efficiency of a heat engine and also the coefficient of performance of refrigerator and also the heat pump. Right? Now the thermodynamic process or the cyclic process take place in heat engine and also refrigerator are reversed to each other. That means whatever the process take place in heat engine, the principle is that the heat energy is converted into the work. Now in refrigerator, if this process take place in heat engine, this process is reversed. So there is the working of the refrigerator or the heat pump. Refrigerator absorbs the heat from the chamber and release the heat into the surrounding at low temperature. Okay. Now on the base of this, today we are going to discuss about the second law of thermodynamics. Here the two scientists named as the Kelvin Planck and Clausius give the different statement of second law of thermodynamics. This statement depends on the working of heat engine and also on the working of refrigerator or the heat pump. In cyclic process, what's happened? Initially, the working substance is in initial state. It passes through the numbers of the thermodynamic process and last return back to its original state. Right? Okay. Now, the question is that the statements of the second law of thermodynamics. The scientists Kelvin Planck and Clausius give the statement for second law of thermodynamics, which are as follows. Now, first statement is Kelvin Planck's statement. Kelvin and Planck state the second law of thermodynamics on the basis of working of the heat energy. Heat energy is heat engine. Heat engine converts the heat energy into the work. But it can't convert the 100% of heat energy into the work. So here on the base of this, the Kelvin Planck statement about the second law of thermodynamics is that no process is possible whose sole result is the absorption of the heat from a reservoir and the complete conversion of the heat into work. So its statement is that no process, thermodynamic process is possible. So as a result of this process, so whatever the heat is absorbed from the reservoir, it 100% convert into the work. Again, there is no process in thermodynamics for which the result, it absorbs the heat from the reservoir and 100% this heat energy is converted into the work. So this type of the process is not possible. There is the Kelvin Planck's statement about the second law of thermodynamics. Again, the statement is no process is possible whose sole result is the absorption of the heat from a reservoir and the complete conversion of the heat into a work. Right? Okay. So this is the second law of thermodynamics stated by the scientists Kelvin and Planck on the base of the heat engine. No any heat engine or no any thermodynamic process is possible in which the whatever the heat is absorbed is 100% converted into the work. The some heat is released, must be released in the cold reservoir, or it means there is in heat sink. Right? 100% conversion of the heat energy is not possible into the work. So this fact suggested by the Kelvin Planck in this statement that is known as the second law of thermodynamics. After that, Clausius' statement. Clausius suggested that no process is possible whose sole result is the transfer of the heat from colder object to the hotter object. Now Clausius also suggested or stated the second law of thermodynamics in such a way that there is no process is possible as a result of this process. So whatever the heat energy is absorbed from the colder object is directly transferred to the hotter object without doing any work. So this type of the process is not possible. There is the statement of Clausius about the second law of thermodynamics. Again, no process is possible whose sole result is the transfer of the heat from a colder object to a hotter object. That means we know that the heat energy is always transferred or the moving from one place to the another place. That means from the higher temperature to the lower temperature. Now this process is reversed. According to the Clausius statement, no process is possible. As a result of this process, the heat is directly transferred from the colder object to the hot object. Actually, the heat is flowing from the object which is at higher temperature to the object which is at low temperature. So here there is the inverse statement is that no process is possible whose sole result is that the heat transfer or the transfer of the heat from the colder object to the hotter object. Heat is never transferred from the cold object to the hot object. So these two are the statement of second law of thermodynamics, or these two statements suggested by Kelvin, Planck and Clausius. These statements are known as the second law of thermodynamics. Clear it? Okay. After that, what is the irreversible and reversible processes? In our life also we know that the some process is completely, not completely, partially reversed. That means we get the initial state. While in some processes we never obtain the initial state. So this type of the processes are the types of the irreversible and reversible processes. Right? Now the question is that notes all reversible and irreversible process. So first we discuss about the irreversible process. For that purpose, we consider a process in which a thermodynamic system goes from one initial state I to the final state F. During the process, the system absorbs the heat Q from the surrounding and performs the work W on it. To explain the irreversible process, we consider the one system. Right? Or we consider a process in which a thermodynamic system goes from initial state I to the final state F. During this process, the system absorbs the heat from the surrounding and performs the work W on it. Okay. If this process reverses and bring the both system and surrounding to their initial state with no other effect anywhere. For most processes in nature, this is not possible. Like to get way. So here we consider the one process. In this process, here there is the what is the working substance? There is a thermodynamic system. This system absorbs, there is the initial state I. Absorb the heat from the surrounding, and as a result, it goes to the final state F. So as the heat is absorbed by the system, therefore the work performed by the system to go from initial to the final state. Right? If this process is reversed, and again we return back from final to the initial state. Right? And we bring the system in initial state and the surrounding to their initial state with no other effect anywhere. So it is possible to bring the system from final to the initial state without any changes occurs. That means, what are the changes occurs when we go from initial to the final state? The same step performed by the system to return back from F to I, that means the final to the initial. So that is not possible. Therefore, this process is irreversible process. This process is irreversible process. Physically, we bring the system and surrounding from final to the initial state. But what are the changes occur when we go from initial to the final? The same process does not take place when we return back from final to the initial. Therefore, this process is not reversible. That is the irreversible process. Clear this thing? Okay. Again, consider a process in which a thermodynamic system absorbs the heat. But the thermodynamic system goes from initial state I to the final state F. During this process, the system absorbs the heat from the surrounding and performs the work on it. As a result, the system goes from initial to the final. During this process, here the numbers of the thermodynamic states are changes. Temperature, pressure, volume, right? Exchange of the heat, and we attain the final state F. Now, as we reverse this process and return back from final to the initial, we bring the system and surrounding into the initial state. But what are the changes occurs when we are going from initial to the final? The same changes does not occur when we return back from final to the initial state. And due to that reason, this process is not reversible. That is the irreversible process. Now, therefore, the most processes in nature is irreversible processes. Now, example of irreversible processes. What are the examples of irreversible processes? The combustion reaction of mixture of petrol and air ignited by a spark cannot be reversed. When we drive a vehicle, the mixture of the petrol and air are fired due to the spark, and the smoke is take place as a result. So this smoke is not directly converted again, return back to its original state, petrol plus air mixture. So that is the irreversible process. Again, the combustion reaction of a mixture of petrol and air ignited by a spark cannot be reversed. Now the second, resting of iron. We know that the resting takes place in iron as we open in the air for the long time. So we never return back to its original position of the iron. So resting of iron, the erosion of rocks. Due to the atmospheric changes, the rocks are erosion. And aging of all animals. All animals are grow day by day. Therefore, the aging of the animals will not return back to its our childhood. Right? We not become again the child. So our age is always increasing order. Therefore, the aging of the all animals. Flow of the heat flowing from the hotter region to the colder region. So this flow of the heat is never returned back. Right? So this type of the processes are the example of irreversible processes. Right? Now, after the example, irreversibility is the nature rule. Nature's the rule is the irreversibility. It arises mainly from two causes. Irreversibility of the nature is mainly arises from the two causes. First is the many processes like a pre-expansion or an explosive chemical reaction take the system to non-equilibrium state. So how the irreversible or the irreversibility in nature occurs due to the two causes. One is that in many processes like a pre-expansion or the explosive chemical reaction, the system to non-equilibrium state. During this process, the system is at each and every step is in non-equilibrium state. Okay. Now next, in most processes like the friction, viscosity and other dissipating effects are present and can be minimized but not fully eliminated because all these processes are irreversible. In our daily life, the friction, viscosity and other dissipative effects are present. These dissipative effects we only minimize but never remove it. Therefore, the 100% the reverse process is not possible because of all these processes are irreversible. In mechanism or the mechanics, due to the viscosity and friction, the some energy is dissipated as a heat. When we try to return back to gain the initial state, we get the initial state but not 100% because the some energy is dissipated as a heat. So this heat energy is not we again obtain. Clear this? So there is a nature irreversibility of the nature. So there is about the irreversible process. Now we are also going to discuss about the reversible process. In reversible process, we 100% return back to its initial state. That means when we are going from initial to the final state. At that time what's happened? During this process, going from initial to the final, from what are the equilibrium state the system is passed. If the system is reversed from final to the initial state and same equilibrium state the system is passed, so there is 100% reverse process. Right? Okay, we discuss it. Now, reversible process. Now, after the discussion of the irreversible process, we know that we can't bring the system and surrounding to its original initial state without any loss of energy in irreversible process. And all the processes occurs in the natures are irreversible process. Now what about the reversible process? Reversible process, a process that can be retraced back in the opposite direction in such a way that the system passes through the same state as in the direct process. And finally the system and surrounding return to their original state with no other change anywhere else is called a reversible process. That means, so there is our, here we consider the process. In this process, here the thermodynamic system initially is in this state I. We want to bring this system into the final state F. Right? Here the two methods to bring the system from initial to the final. One is directly expand the volume and come to the final state. So in initial state the pressure is Pi, volume is Vi and temperature is Ti. While in final state the pressure is Pf, volume is Vf, temperature is Tf. As we suddenly increase the volume initial to the final, so what's happened? Pressure decreases, temperature is also decreases. So here the changes occurs in volume and temperature. And when we return back to the final to the initial, suddenly we compress the system to its initial state. So what's happened? Volume decreases, temperature increases. So here, during the expansion, what are the state the system is passes? What are the stages the system is passes? From the same stages, the system not return back from final to the initial. Therefore, there is the irreversible process. But instead of this, suddenly increase or decrease the volume. So yes, we bring the system in other way. First, the initial state of the system is I, pressure is Pi, volume is Vi, temperature is Ti. Now we slightly increase the volume, or we make the small change in volume. Pressure increases, pressure decreases, and temperature is also decreased. But now listen, what's happened? As we wait for the some time when the equilibrium is established, therefore the change in pressure and temperature is very, very small, we can neglect. After the equilibrium is established, again we increase the volume. Again the small change occurs in pressure and temperature. We wait for the equilibrium is established. So this way we bring the system from initial to the final state by making the small changes in volume. And when we return back from final to the initial, from the same changes occurs, that means by step, when the equilibrium is established, after that we make the change. So this way we return back to the initial state. So that is the reversible process. Here there is the no energy loss take place. Clear this? So this type of the process is the reversible process. For that purpose, a process that can be retraced back in the opposite direction in such a way that the system passes through the same state as in the direct process. Finally, the system and surrounding return to their original states with no other changes anywhere else is called a reversible process. During the expansion, whatever the state we pass, during the compression, the same state we pass. So such process is reversible process. Okay, now the reversible process is an ideal process. Actually, in nature, that is not possible. Some energy loss take place. But this reversible process is an ideal process. It is the basic principle of thermodynamics. That is the basic principle of thermodynamics. A completely reversible process cannot be realized in practice, but under the certain condition, the reversible process can be done. In reality, the 100% reverse process is not occur. It is not possible. That means a completely reversible process cannot be realized in practice, but under the certain condition, the reversible process can be done. 100% reversible process is not possible, but under the certain condition, we can bring the process 100%. Now, for reversible process, the following conditions should be necessary. Now, what are the certain conditions? This condition, under this condition, the process becomes the reversible. Right? First, the process should be quasi-static process. Means the system can be considered to be passing through the equilibrium state during the every stage. In pressure and in temperature have no much difference. Just we discussed that to bring the system from initial to the final state, we make the small change in volume. So as a result, the change in pressure and change in temperature occurs, but this change in pressure and temperature is very, very small. and we wait for the thermodynamic equilibrium is established in new state. After that, again we expand the volume and we bring the system in this. Again the pressure and temperature changes. We wait for the sometime for thermodynamic equilibrium is established. So this way, step by step. That means at each and every stage we wait for the thermodynamic equilibrium, or the system is passes through the equilibrium states. So during the each stages. And during each stages, the changes occurs in the pressure and temperature are very small. So that is the first condition. Second is the process must be very slow. Here we wait for the thermodynamic equilibrium is established. Therefore, this process is very slow, not fast. Third is during this process, the dissipative effect like the friction, viscosity and resistive force which are responsible for energy loss can be minimized. So due to the slow process, what are the dissipative effect like as the friction, viscosity, resistive force is also minimized but never becomes zero. Never becomes zero. So in this, that means under this condition, we make the thermodynamic process is mostly probable to the reversible process, not 100% reversible. Because as we bring the system and surrounding from initial to the final state, slowly, but here the energy loss take place at each and every stage due to the friction, viscosity and resistive forces. So this dissipation of the energy is never returned back. Right? So to going from initial to the final stages, as the process is very small, therefore the energy loss take place is also loss, that means the minimize. Clear this? So that is the discussion about the reversible process. Right? Reversible is an ideal process. Right? That is the basic principle of thermodynamics. That is not possible 100%. But as we bring the system and we wait for the thermodynamic equilibrium for each and every stage, so this process may be the reversible process. Clear it? Okay.